Cookbook for the Universe 9, The Delta Phenomenon, a universal framework for evolution and reality. Imagine the universe not as a static expanse, but as a dynamic symphony, each note a shift, each chord a transformation, playing across cosmic time. This symphony is seen guided by a fundamental principle, the delta phenomenon, a framework that unveils the rhythms and mechanisms governing existence itself. At its heart, the delta phenomenon describes how entities, dimensions, and forces evolve through cycles of abstraction and synthesis. It reveals a universe in perpetual motion, where every transition between states, a delta, serves as a step in an eternal dance of creation, conservation, and transformation. From the interplay of galaxies merging under gravitational waves to the thermal oscillations of solar winds shaping planetary climates, the delta phenomenon operates as a universal law. It harmonizes with nature's most fundamental processes, embodying evolution itself. Imagine a spiral that starts as a single point and expands outward, with each loop representing a delta, a transition from one state to another. At each turn, the spiral branches into smaller, finer loops, symbolizing the layering of complexity. This dynamic structure, both recursive and expansive, embodies the delta phenomenon as principles. By Orion Carl Daly 1. Aka. Essay on Relative Gravity to describe the mechanics of the universe 9.1 Theoretical point of view. Here, the dynamics of polymorphism are described. Generalized. The dynamics are referred to as a delta phenomenon, which represents some object or entity with respect to states of expression in polymorphism. 1. The delta phenomenon is perceived as the basis of dimension that exists in a body. 2. It holds that in terms of the observance on an entity, a prior and future iteration of that entity will also exist where the entity in its current state does not exist. 3. The delta phenomenon applies to an entity or a family of entities such that each may have a unique personification of the delta phenomenon, yet be part of the same delta phenomenon. 4. Consequently, the delta phenomenon, although unique, can parallel itself. 4. Hence a point of reference can be established from one category of existence to another through the relationship of uniqueness expressed through symmetry. Consider if Principle 1, the basis of dimension within a body, represents being, and Principle 2, the temporal observation of past and future iterations, represents time. Then Principle 3 could indeed represent relational existence, where the delta phenomenon manifests in unique personifications across entities or families of entities, connecting them through shared cyclical phenomena. 9.1.1 Reframing the principles. Principle 1, being as the foundation. The delta phenomenon is the basis of dimension and existence within a body. This principle anchors the existence of any entity, defining its unique presence as a state of being in the universe. Principle 2, time as a temporal framework. Every entity's current state reflects the interplay of its past and future iterations. This principle introduces the dimension of time, suggesting that without a temporal connection, an entity cannot exist in its observed state. Principle 3, relational existence being time. If being and time coexist, then their ratio or interplay manifests as relational existence. This principle illustrates how the delta phenomenon applies across entities and families, where unique personifications evolve within shared frameworks of cyclical phenomena. By Orion Carl Daly 2. Cookbook for the Universe 9.1.2 Implications of being time equals relational existence. A. Dynamic interactions. Relational existence connects unique entities, emphasizing their interactions and mutual evolution. Each entity's existence influences and is influenced by others, creating networks of interdependence. B. Cyclical universality. While each entity or system is unique, all share foundational properties that bind them within the delta phenomenon's cycles. This underscores the symmetry and conservation inherent in the phenomenon. C. Parallelism and symmetry. Relational existence allows entities to mirror and resonate with each other, even across different scales or dimensions. Symmetry emerges not from static repetition, but from dynamic relationships evolving over time. D. Extension through Principle 4. Principle 4, parallelism and symmetry. Unique entities can parallel themselves, creating points of reference between categories of existence. Symmetry becomes the bridge between these parallels, enabling transitions, transformations, and harmonized interactions. Principle 4.a, points of reference. Through the relationship of uniqueness expressed in symmetry, entities establish connections across dimensions and states. This creates a cohesive framework for evolution, where individual and collective phenomena align within the broader context of the delta phenomenon. 9.1.3 Philosophical context. By Orion Carl Daly 3. Aka. Essay on Relative Gravity to describe the mechanics of the universe if being time equals relational existence. This framework parallels foundational concepts in philosophy and physics. A. Ontology and temporality, echoing Heidegger's notion of being and time. This formulation explores how existence and temporality interplay to define reality. B. energy and harmony, aligning with principles of harmonic resonance. The delta phenomenon captures how energy and time synchronize entities within dynamic systems. C. Evolutionary connectivity. From the quantum realm to galactic scales, relational existence underscores the interconnected evolution of all phenomena. By conceptualizing being-time as relational existence, we unlock deeper insights into the delta phenomenon's principles. This perspective not only refines our understanding of evolution and interaction, but also emphasizes the universal interconnectedness that binds all dimensions, entities, and forces in a perpetual cycle of transformation. 9.2 The Delta Phenomenon, a universal rhythm of transformation. The delta phenomenon is a conceptual model that bridges the origins of the universe, the principles of evolution, and the behaviors of natural phenomena. It unifies dimensions, entities, and forces into a cohesive framework of perpetual transformation and continuity. Here, the delta phenomenon is explored in detail, showcasing how it illuminates the universe's grand design and its evolutionary processes. 9.2.1 Evolution via ex nihilo. A. Origin framework. Ex nihilo, akin to a creation from the void, postulates that all entities, including singularities and particles, are derivatives rather than absolute origins. These derivatives emerge through iterative abstraction and polymorphism, adhering to the conservation laws. B. Wavelengths and blackbody radiation. The delta phenomenon demonstrates that blackbody radiation thermal energy is a primordial derivative of transitions between heat and cold, which forms the basis for dimension and time. This progression evolves into spatial fabrics, representing the coexistence of particles as waves. 9.2.2 The Carnot cycle and dimensional evolution. A. Thermodynamics as a catalyst. The transitions between heat and cold within Carnot cycles are modeled to explain the genesis of wavelengths, dimensions, and ultimately particles. These cycles form a harmonic mean expressed through resonance frequencies that underlie the formation and evolution of particles. By Orion Carl Daly 4. Cookbook for the Universe. B. Dimension as perspective. Dimensions are considered derived states, with transitions between them occurring through iterations of the delta phenomenon. The interplay of heat and cold generates relative time and dimension, forming the basis for further evolution. 9.3 The Carnot cycle. The cosmic engine. The engine driving the delta phenomenon's rhythm is the Carnot cycle. Known as the most fundamental model for energy transformation, the Carnot cycle governs the interplay of heat and cold, expansion and compression, creation and dissolution. Its four stages: ISA, thermal expansion; adiabatic expansion; ISA, thermal compression; and adiabatic compression mirror the cosmic forces that stretch dimensions, shape galaxies, and give birth to stars. Within this cycle lies the origin of vector ZR, the dynamic pulse of oscillatory energy that bridges dimensions and sustains the evolution of forces. This vector, born from thermodynamic interactions, weaves together the past, present, and future, enabling the seamless transition of energy and matter. 9.4 Framing evolution through the delta phenomenon. The delta phenomenon offers an unparalleled perspective on evolution, not limited to biological systems, but extending to cosmic and atomic realms. Whether through the gravitational superposition of galaxies, the harmonics of subatomic particles, or the adaptive changes in ecosystems, it reveals a universe intricately connected across scales. Time itself becomes a delta, the difference between moments stretched and compressed through cycles of transformation. Each cycle reflects the conservation of fundamental principles: symmetry, equilibrium, and inheritance, while manifesting infinite diversity. 9.5 The promise of the delta phenomenon. The delta phenomenon is not merely an abstract framework, it is the essence of reality. It reframes questions about the origins of the universe, the behavior of forces, and the nature of time. It bridges the macrocosm and the microcosm, uniting classical physics with the frontiers of quantum theory and beyond. This narrative sets the stage for a profound exploration of the delta phenomenon's principles and applications, illuminating the interconnected fabric of existence. 9.6 Foundations of the delta phenomenon. 9.6.1 Polymorphism, the core of transformation. By Orion Carl Daly 5. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Polymorphism is the principle that underlies the delta phenomenon. It posits that entities and forces, while unique in their expression, share inherited properties that evolve across cycles. The universe, in this view, is an alternator, constantly transforming while conserving core traits. 9.6.2 Ex nihilo and the birth of dimensions. The delta phenomenon begins with ex nihilo, out of nothing, suggesting that entities emerge not from a singular origin, but through iterative abstraction. From this void, dimensions, forces, and entities unfold as derivatives, adhering to conservation laws while evolving through cycles of abstraction and synthesis. 9.6.3 Time as a delta. Time itself is conceptualized as a delta, the difference between moments. Through the delta phenomenon, time stretches, compresses, and loops, forming a continuum that accommodates diverse states of existence. This framework bridges cosmic scales, from galactic orchestration to subatomic dance. 9.7. Principles of the delta phenomenon. 9.7.1 Basis of dimension. The delta phenomenon defines dimensional transitions. Every shift in space-time is a delta, an evolutionary step that reflects the interplay of causality and potential. Dimensions, as derived states, emerge and evolve through these transitions. Dimensions emerge as transitions between states of energy. The delta phenomenon provides the mechanism for these transitions, ensuring that dimensions evolve iteratively. The early universe expanded from a singularity into multi-dimensional space, guided by energy fluctuations that resonate with the delta phenomenon. 9.7.2 Temporal layers. Every entity is a composite of past, present, and future states. The delta phenomenon ensures that these states coexist, forming a temporal fabric where causality and potential interact dynamically. Analogy: a river flowing through time carries the imprints of its past paths while carving new channels, much like how forces evolve. 9.7.3 Families of entities. Entities evolve individually and collectively. Like stars in a galaxy or particles in a field, they share evolutionary patterns while maintaining unique characteristics, governed by the delta phenomenon. 9.7.4 Symmetry and parallelism. Symmetry is conserved across cycles, allowing entities to mirror and interact through shared properties. This principle reveals deep connections, whether in physical by Orion Carl Daly 6. Cookbook for the Universe Forces, Biological Systems, or Cosmic Events. 9.7.5 Cyclic nature. The delta phenomenon is inherently cyclic. Its recursive patterns, akin to wave forms or Mandelbrot sets, create layered complexity. Each loop builds upon the previous, driving evolution forward. Evolution is inherently cyclic, resembling the repetitive loops of the Carnot cycle. Each loop builds upon the last, creating layered complexity. Example: galactic formation follows cycles of expansion, star formation, and contraction, black hole creation. 9.7.6 Object-oriented evolution. Entities inherit and adapt properties over time, mirroring object-oriented programming's principles of inheritance and polymorphism. Forces evolve uniquely while retaining their fundamental traits. 9.7.7 Singularities as transitional phases. Singularities, such as black holes or the Big Bang, represent points of maximum delta, moments of extreme transition where new dimensions or universes emerge. Singularities, like those in black holes, represent extreme deltas where transitions between dimensions reach their apex. These points of maximum change are where new universes or states of matter emerge. 9.8 Applications of the delta phenomenon. The delta phenomenon extends across scales, unifying phenomena from cosmic evolution to biological processes. 9.8.1 Cosmic evolution. Galaxies as deltas. Merging galaxies exhibit the delta phenomenon through gravitational superposition, forming new equilibrium states. Black holes as spatial induction engines. Black holes convert energy into oscillatory currents vector ZR, radiating mass energy through harmonic means. 9.8.2 Atomic interactions. Particle evolution. Subatomic particles evolve through resonance frequencies dictated by the delta phenomenon, ensuring stability across quantum transitions. Quantum coherence. The oscillatory nature of particles mirrors the harmonic phases of the Carnot cycle. 9.8.3 Biological evolution. Adaptive equilibrium. Species evolve by maintaining dynamic equilibrium with their environments, reflecting the thermal dynamics of the Carnot cycle. By Orion Carl Daly 7. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Genetic mutations as deltas. Small shifts in genetic material parallel the incremental changes of the delta phenomenon, driving evolutionary complexity. 9.9 The universality of the delta phenomenon. The delta phenomenon demonstrates that evolution is a universal principle, applicable across all domains of existence. 9.9.1 Time as a continuum. Time is not linear but cyclic, with each iteration contributing to the continuity of existence. The delta phenomenon allows time to stretch, compress, and loop, creating diverse states of reality. 9.9.2 Energy conservation across scales. The delta phenomenon aligns with the Carnot cycle to ensure that energy transitions are efficient and coherent, preserving symmetry across scales. 9.9.2.1 Analogy. A symphony's harmony persists even as individual notes evolve, much like how forces and dimensions retain coherence. 9.9.2.2 Harmonic interactions. The harmonic mean governs interactions between entities, from molecules to galaxies. This principle explains why systems naturally settle into stable configurations. 9.9.2.2.1 Harmonic mean and black hole dynamics. Black holes, within the RG framework, are reconceptualized as spatial induction engine sources of mass and energy interconnected via harmonic means. A. Harmonic mean and resonance. Role in evolution. The harmonic mean ensures stability and coherence in the evolution of particles and manifolds by aligning their interactions with the speed of light. This synchronization prevents divergence in dynamic systems, maintaining a cohesive structure across scales. Black hole currents. The alternating currents within black holes form the basis for their synchronicity with other black holes. These currents adhere to the harmonic mean. Black hole currents. The alternating currents within black holes form the basis for their synchronicity with other black holes. These currents adhere to the harmonic mean, creating interconnected networks that radiate relative masses and sustain the cyclical evolution of the universe. B. Vector ZR and energy dynamics. Current is a catalyst. Within the delta phenomenon, the Carnot cycle dynamics form the basis for vector ZR, a harmonic derivative representing oscillatory energy. By Orion Carl Daly 8. Cookbook for the Universe. This vector aligns with the harmonic mean, producing currents that radiate mass and sustain the interplay of forces within the universe. C. Interconnection and synchronization. Spatial induction and equivalence. Black holes maintain constant connections through effect while sharing inconstant connections through equivalence. This dual relationship allows for the perpetual exchange of energy and mass, forming a network of synchronized black holes that serve as engines of evolution. 9.9.2.2.2 Implications for evolution and mass creation. A. Particle evolution. Through the delta phenomenon, particles evolve as manifolds, where resonance frequencies dictate their states and transformations. This process aligns with the harmonic mean, ensuring symmetry and conservation in their transitions. B. Mass creation via black holes. Black holes act as manifolds that emit mass through their spindle currents. The relative force generated by these currents aligns with the harmonic mean, creating stable and coherent structures across cosmic scales. C. Universal continuity. The delta phenomenon ties all elements of the universe, particles, black holes, and dimensions into a coherent framework of perpetual evolution, grounded in symmetry and conservation. By integrating the delta phenomenon, harmonic mean, and the dynamics of black holes, RG provides a comprehensive model for understanding the evolution of the universe as a continuum of interconnected phenomena. Each element, from ex nihilo to black holes, contributes to a unified theory of existence. By Orion Carl Daly 9. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. 9.10. The Carnot Cycle and Energy Evolution. 9.10.1 The Cosmic Engine. The Carnot cycle, the most fundamental thermodynamic model, serves as the engine of the delta phenomenon. Its four stages, iso, thermal expansion, adiabatic expansion, iso, thermal compression, and adiabatic compression, mirror the universal dynamics of energy flow and transformation. 9.10.2 Vector ZR and energy dynamics. Vector ZR, derived from the Carnot cycle, represents oscillatory energy within the delta phenomenon. This vector aligns with harmonic principles, enabling the creation and evolution of forces, dimensions, and entities. 9.10.3 Thermodynamics and dimensional transitions. The interplay of heat and cold generates wavelengths, dimensions, and particles. For instance, the Sun's radiative zones reflect the Carnot cycle iso, thermal phases, while its convection zones mirror adiabatic stages, exemplifying thermal energy's role in shaping celestial bodies. 9.11 Applications of the delta phenomenon. 9.11.1 Cosmic evolution. Galactic formation. The delta phenomenon explains how galaxies evolve through gravitational superposition, radiative equilibrium, and symmetry conservation. Orbital dynamics. Solar systems align with galactic threads through radiated gravitational potentials, maintaining harmonic mean-based stability. By Orion Carl Daly 10. Cookbook for the Universe. 9.11.2 Biological evolution. Dynamic equilibrium. Species adapt to environmental pressures to maintain equilibrium, akin to celestial bodies finding gravitational balance. Genetic variability. Mutations mirror delta shifts, driving evolutionary processes through small, cumulative changes. 9.11.3 Subatomic and quantum realms. Particle evolution. Subatomic particles evolve through resonance frequencies dictated by the delta phenomenon. Quantum symmetry. Wave-particle duality and superposition reflect the principles of parallelism and symmetry. 9.11.4 Philosophical implications. 9.11.4.1 Interconnectedness. The delta phenomenon reinforces the idea that all entities and forces are interconnected. Every change ripples across the universe, influencing all scales of existence. 9.11.4.2 Continuity and creation. Creation is ongoing, with existence constantly refined through cycles of differentiation and synthesis. The universe in this view is a dynamic, ever-evolving system. 9.1.1.4.3 Potential and actuality. Latent possibilities manifest into reality through iterative changes. The delta phenomenon bridges potentiality and actuality, explaining how transformation occurs across dimensions and states. 9.12. A unified model of evolution and existence. 9.12.1 Time and space. The delta phenomenon offers a framework where time and space are dynamic participants in evolution. Time compresses and stretches, while dimensions curve and intersect, adapting to the forces at play. 9.12.2 Energy and harmony. The Carnot cycle's principles, integrated with the delta phenomenon, reveal how energy flows harmoniously across scales. Solar winds, black holes, and molecular bonds all demonstrate these principles in action. By Orion Carl Daly 11. Aka. Essay on Relative Gravity to describe the mechanics of the universe. 9.12.3 Universal continuity. The universe is a continuum of interconnected phenomena. From ex nihilo to the harmonic mean, the delta phenomenon unifies forces, dimensions, and entities into a coherent evolutionary narrative. 9.12.4 Transcending traditional scientific frameworks. The delta phenomenon transcends traditional scientific frameworks, offering a unifying perspective on the universe's origins, evolution, and principles. It reframes time, space, and forces as dynamic, interconnected participants in an eternal cycle of transformation. Whether through the interplay of galaxies, the behavior of particles, or the evolution of life, the delta phenomenon illuminates the universal rhythms that define existence. 9.13 Key aspects of the delta phenomenon. 9.13.1 Basis of dimension. The delta phenomenon exists as the underlying mechanism for dimensional transitions. For example, the movement from one spatial or temporal state to another can be thought of as a delta, the difference between two states, which defines evolution in space and time. 9.13.2 Temporal states. Every entity exists as a composite of its past, present, and future states. The delta phenomenon ensures that an entity's current state is a product of these temporal layers, reflecting the interplay of causality and potential. 9.13.3 Families of entities. The delta phenomenon governs how entities evolve both individually and collectively. Entities sharing similar properties, such as particles in a quantum field or stars in a galaxy, follow parallel patterns of evolution while retaining their uniqueness. 9.13.4 Parallelism and symmetry. The delta phenomenon allows entities to mirror each other, establishing relationships through shared properties. This is crucial for understanding concepts like symmetry in physics, where mirrored forces or particles reveal deep connections. 9.13.5 Cyclic nature. The phenomenon is inherently cyclic, akin to natural systems such as waveforms, or recursive mathematical structures like Mandelbrot sets. These cycles represent iterative refinement, where each loop builds upon the previous one, creating a layered complexity. 9.13.6 Object-oriented evolution. In the delta phenomenon, entities inherit properties while differentiating themselves over time. This is analogous to object-oriented programming, where objects evolve through inheritance and polymorphism while retaining fundamental traits. By Orion Carl Daly 12. Cookbook for the Universe. 9.13.7 Singularities as transitional phases. Singularities, like those at the centers of black holes or during the Big Bang, can be understood as points of maximum delta. These represent moments where the transition between states is so extreme that new dimensions or universes emerge. 9.14 How the delta phenomenon operates in reality. 9.14.1 Evolution of forces and dimensions. Forces like gravity, electromagnetism, and nuclear interactions are seen as expressions of the delta phenomenon. They evolve iteratively, maintaining symmetry while adapting to their contexts. For example, gravity as a force evolves as mass-energy relationships change over cosmic timescales. 9.14.2 The relationship of heat and cold in the universe. By integrating the principles of the Carnot cycle into this evolutionary perspective, we gain a deeper understanding of the universe as a self-organizing system. The cosmos emerges as a vibrant tapestry, woven by the forces and dimensions that respond dynamically to the thermal flows shaping existence. Forces and dimensions are not static entities. They are dynamic participants in the ongoing evolution of the cosmos. Like a river carving a canyon over millennia, forces such as gravity, electromagnetism, and nuclear interactions both shape and are shaped by the entities they influence. This mutual interplay highlights the adaptive nature of the universe, where forces respond to changes in mass, energy, and context, sculpting the cosmos in a dance of perpetual transformation. 9.14.3 The Four Stages of Transformation. By Orion Carl Daly 13. Aka. Essay on Relative Gravity to describe the mechanics of the universe. The Carnot cycle, with its four stages: ISA, thermal expansion, Adiabatic expansion ISO, thermal compression. An adiabatic compression provides a framework for understanding how heat and cold drive the creation and evolution of forces and dimensions. A. Isothermal expansion. As energy flows into a system, it causes an expansion that mirrors the early phases of the universe, where heat provided the impetus for dimensional unfolding and the emergence of fundamental forces. B. Adiabatic expansion. In a phase of cooling without heat exchange, energy disperses, creating the scaffolding for gravitational and electromagnetic fields to take shape, carving dimensions as the cosmos expands. C. Isothermal compression. As systems contract under the influence of radiative cooling, energy is redistributed. This phase plays a role in forming localized phenomena, such as galaxies and stars, where forces converge in a structured balance. D. Adiabatic compression. The compression of energy without heat loss generates singularities, such as black holes, where dimensions and forces reach extremes, forming seeds for new universes or stellar systems. These thermal cycles highlight how heat and cold govern the interplay of forces and dimensions, driving the perpetual evolution of the cosmos. Dimensions stretch, curve, and intersect, adapting to these thermal rhythms. Forces too evolve in response, creating a universe that is not fixed but alive with transformation. 9.14.3.1 Time as a continuum. Time itself is a delta, the difference between moments. The delta phenomenon allows time to stretch, compress, and loop back on itself, forming a continuum that accommodates diverse states of existence. A. Galactic and atomic scales. The phenomenon scales seamlessly, from the grand orchestration of galaxies to the intricate dance of subatomic particles. This universality hints at a unifying principle that bridges the cosmic and quantum realms. B. Harmonic interactions. The delta phenomenon aligns with the harmonic mean, where interactions between entities find equilibrium through shared frequencies. This explains why systems, from molecules to solar systems, often settle into stable configurations. By Orion Carl Daly 14. Cookbook for the Universe 9.14.3.2 Solar Winds, a narrative of energy resonance. Following the principles outlined in the Carnot cycle, solar winds serve as a natural manifestation of thermal resonance within the solar system. These winds, originating from the Sun's corona, embody the cyclical transformation of energy across spatial and temporal dimensions, illustrating the dynamic interplay of heat, motion, and resonance, a foundation of the delta phenomenon. Solar winds begin their journey in the corona, where extreme temperatures exceeding 106 K 10·6 generate pressure gradients, magnetic oscillations, and plasma flows. The Sun's magnetic field, shaped by the dynamo effect, creates a resonant environment where waves such as alpha waves transfer energy to charged particles. This resonant release of energy parallels the isothermal expansion phase of the Carnot cycle, where the corona acts as the system's high-temperature reservoir. As the solar wind accelerates away from the sun, it enters a phase akin to adiabatic expansion. Here, particles experience a cooling effect as they expand into the vast, low-density interplanetary medium, losing thermal energy while maintaining dynamic motion. This phase captures the essence of energy propagation through spatial time, resonating with the harmonic oscillations of the heliospheric environment. Upon reaching planetary systems, the solar wind interacts with magnetospheres, atmospheres, and conductive surfaces, mirroring the isothermal compression phase. Energy from the solar wind induces electromagnetic currents, excites auroral displays, and transfers thermal energy, all while maintaining a resonant balance with the planetary environment. The solar wind thus serves as a conduit for energy exchange, synchronizing the Sun's influence with the planets through the framework of relative gravity. Finally, the solar wind undergoes adiabatic compression as it interacts with the heliospheric current sheet, where magnetic field lines and charged particles realign, refocusing energy into higher density regions. This cyclical compression mirrors the closing phase of the Carnot cycle, ensuring that energy is conserved and redistributed throughout the solar system. The solar wind, as a resonant system, reflects the harmonic nature of the delta phenomenon. It demonstrates how energy cycles through expansion, compression, and redistribution, creating a dynamic equilibrium that connects the Sun to its orbiting bodies. This interplay of thermal resonance and harmonic relationships underscores the unifying principles of relative gravity, revealing the intricate choreography of energy, time, and space within the cosmos. By Orion Carl Daly 15. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 9.14.3.3 Applying the Carnot Cycle to Heavenly Bodies. The Carnot cycle is a theoretical thermodynamic model that describes the most efficient possible engine operating between two heat reservoirs. While traditionally applied to mechanical systems, it provides an interesting framework to consider the thermodynamics of heavenly bodies like stars or the Sun. 9.14.3.3.1 Heat reservoirs in space. In the context of stars, the hot reservoir is the core of the star, where nuclear fusion occurs at extreme temperatures. For example, for the Sun, approximately 15 million K15, text million K 15 million K. The cold reservoir can be thought of as outer space, a near absolute zero temperature environment around 2.7 K due to the cosmic microwave background radiation. 9.14.3.3.2 Energy flow in stars. Heat source. Nuclear fusion at the star's core generates immense heat and energy, primarily as light and other electromagnetic radiation. Heat sink. The energy is radiated into space, with some contributing to warming nearby celestial bodies like Earth. The star operates like a continuous heat engine, converting thermal energy into radiative energy, light and heat. 9.14.3.3.3 Efficiency in terms of the Carnot cycle. The theoretical efficiency of a Carnot engine is expressed as. This implies nearly 100 theoretical efficiency due to the immense temperature difference between the core and space. However, real-world factors such as neutrino emissions, convection losses, and energy redistribution reduce actual efficiency. By Ryan Carl Daly 16. Cookbook for the Universe 9.14.3.3.4 Cycles of energy within stars. Convection zones. Heat moves through the star via convection in certain layers, analogous to phases in the Carnot cycle. Radiative zones. Radiation transfer occurs in other layers, analogous to the ISA, thermal expansion compression phases. 9.14.3.3.5 Entropy considerations. Stars are high entropy systems, constantly increasing entropy as they radiate energy into space. The Carnot cycle assumes reversible processes, but the real energy transfer in stars includes irreversible processes like fusion and radiation. 9.14.3.3.6 Astronomical implications. Understanding the thermodynamics of stars through the lens of the Carnot cycle helps in modeling their life cycle, energy output, and potential changes over time. In multi-star systems or galaxies, this framework could explore energy interactions between stars and their surrounding environment. 9.14.3.3.7 Broader considerations. Heat engines in the cosmos. Besides stars, other celestial systems like accretion disks around black holes or gas giants might operate as thermodynamic systems with Carnot-like cycles. Radiative balance. The Sun's role as a quasi-steady-state heat engine emphasizes radiative balance, impacting Earth's climate and the evolution of the solar system. This approach links thermodynamics with astrophysics, expanding our understanding of energy dynamics in space. The delta phenomenon provides a unifying lens to examine the interconnected nature of reality, where each entity and event is both a cause and an effect within a vast, dynamic web. By reframing existence as a continuum of cycles and equilibria, it sheds light on foundational questions about the universe, evolution, and our place within it. 9.15.1 Interconnectedness, the web of existence. The delta phenomenon reinforces the principle that no entity exists in isolation. Every shift or transformation ripples outward, influencing other systems. This mirrors the principle of causality across scales, from the quantum interactions of particles to the ecological networks that sustain life. The delta phenomenon's emphasis on shared properties and relational dynamics highlights a universe where everything is interdependent. 9.15.2 Continuity in creation, the cyclical nature of existence. Creation is not a singular event but an ongoing process of differentiation, refinement, and synthesis. The delta phenomenon illustrates how entities emerge, evolve, and transform within cycles of change, perpetually adapting to their environments while contributing to the broader system. 9.15.3 Potential and actuality, bridging possibilities and realities. Through iterative changes, the delta phenomenon bridges potentiality and actuality. Latent possibilities manifest as tangible realities, driven by shifts in equilibrium and contextual forces. This principle applies not only to cosmic evolution, but also to the emergence of life and consciousness. 9.15.4 Relative gravity and the delta phenomenon, a framework for evolution. The intersection of relative gravity and the delta phenomenon introduces a transformative perspective on evolution. This framework reframes biological, cosmic, and systemic evolution as processes of equilibrium seeking and adaptation to dynamic pressures. 9.15.5 Evolution as equilibrium seeking behavior. Evolutionary adaptation mirrors the search for equilibrium within the delta phenomenon. A. Dynamic balance. Species evolve traits M1 in response to environmental pressures M2, akin to relative equilibrium M1D2 equals M2D1. B. Adaptive divergence. The distances D1, D2 reflect the degree of adaptation required to restore equilibrium, highlighting how organisms navigate their environments. by Ryan Carl Daly 18. Cookbook for the Universe 9.15.6 Radiative Fields as Life-Sustaining Dynamics. Living organisms are radiative entities that exchange energy with their surroundings. A. Gravitational analogy. Just as celestial bodies interact through gravitational fields, organisms influence and adapt to their ecosystems. B. Delta shifts, genetic mutations and environmental changes disrupt equilibrium, prompting evolutionary responses. 9.15.6 Biological evolution. Adaptive resonance. Genetic variation. Random mutations mirror delta shifts, introducing incremental changes that accumulate into evolutionary innovation. Environmental pressures. Predation, competition, and climate changes act as dynamic fields influencing survival, akin to gravitational forces. 9.15.7 Cosmology. Galactic and atomic equilibria. Cosmic continuity. The delta phenomenon explains galactic rotations, black hole mechanics, and universal origins through equilibrium dynamics. Atomic stability. Radiative fields govern particle interactions, linking atomic structure to the universe's larger forces. 9.15.8 Evolution of complexity and consciousness. From molecules to minds, the delta phenomenon accounts for the emergence of complexity, from molecular structures to conscious beings. Higher order equilibria. Consciousness represents an advanced equilibrium state where organisms process and radiate information. 9.15.9 Philosophical reflections on the delta phenomenon. A. Interconnectedness and universal resonance. The universe operates as a single, interconnected system, where every entity contributes to and is shaped by the whole. The delta phenomenon emphasizes the relational nature of existence, where shared properties and interactions define reality. B. Creation as an eternal process. Rather than a singular origin, creation is a perpetual cycle of transformation, echoing across cosmic and quantum scales. This insight challenges static views of the universe, offering a dynamic narrative of continuous evolution. By Ryan Carl Daly 19. Aka, Essay on Relative Gravity to describe the mechanics of the universe. C. Bridging the cosmic and the personal. The delta phenomenon connects the vastness of galaxies with the intricacies of human existence. It invites us to see ourselves as active participants in the universe's evolution, bound by the same principles that govern stars and particles. 9.15.10 Enhancing specific examples, linking principles to observations. Solar winds as thermal resonance. Solar winds illustrate the Carnot cycle's phases, providing a tangible manifestation of the delta phenomenon. ISA, thermal expansion. Energy escapes the sun's corona, initiating outward flow. Adiabatic expansion. Cooling particles disperse into interstellar space, maintaining equilibrium. Mass extinctions as delta events. Extinction events disrupt global equilibrium, forcing rapid adaptation and innovation. These mirror delta shifts in relative gravity, where disruptions lead to the emergence of new systems. 9.15.11 Friction. Friction and currents in galactic dynamics provide a compelling analogy to thermodynamic and electromagnetic processes, offering insights into how galaxies distribute energy and generate relative mass. Galactic dynamics are governed by the interplay of rotation, gravitational forces, and energy flows, with friction acting as a catalyst for creating currents within these systems. 9.15.11.1 Rotational friction hypothesis. Galaxies rotate as vast, interconnected systems. Their angular momentum induces interactions between matter, such as stars, gas, and dark matter. This interaction generates a form of rotational friction, where energy is transferred and dissipated throughout the system. Similar to friction in mechanical systems, this process can create currents of energy and momentum, which travel along the spiral arms of galaxies. These currents contribute to the propagation of energy through the galactic structure, allowing for the formation and maintenance of its dynamic stability. They also influence the distribution of mass and energy within the galaxy, forming regions of density that align with observed structures, such as spiral arms and galactic bulges. By Ryan Carl Daly 20. Cookbook for the Universe 9.15.11.2 Friction-induced currents and energy transfer. A. Energy redistribution. Friction generates currents that transfer energy from the galactic core to its outer regions. This energy transfer mirrors thermodynamic cycles, where high-energy regions' hot cores interact with low-energy regions' cooler outer arms. B. Creation of relative mass. These currents act as conduits for energy, converting it into relative mass, expressed as m equals Et, where E is energy and T is the temporal scale. This process mirrors the principles of energy to mass equivalence and relative gravity. C. Gravitational feedback loops. The energy flowing through these currents creates gravitational feedback loops, reinforcing the structural coherence of the galaxy. This ensures that the spiral arms maintain their shape and the galaxy as a whole retains its stability over cosmic timescales. 9.15.11.3 Carnot cycle analogy. The energy flow in galaxies can be further compared to the Carnot cycle in thermodynamics. A hot reservoir, the galactic core, rich in energy from processes like nuclear fusion and accretion, serves as the hot source. B cold reservoir, the outer arms and intergalactic space act as the cold sink. C energy efficiency. The efficiency of energy transfer between these regions can be modeled using E equals 1 minus CTH, where TH is the temperature of the core and C is the temperature of the outer regions. D magnetic and electromagnetic currents. Galactic dynamics also involve electromagnetic interactions. As stars and gas clouds move through magnetic fields, they induce electromagnetic currents, similar to the dynamo effect. These currents further regulate the energy flow and align with galactic rotation, creating a self-sustaining network of energy distribution. E implications for spiral galaxy evolution. Formation of density waves. Friction-induced currents shape the density waves that give spiral galaxies their iconic structure. These waves act as stabilizing mechanisms, maintaining the spacing and rotation of the arms. Synchronization across scales. The currents create a resonant system, linking the microcosmic processes within stars to the macrocosmic dynamics of the galaxy. This ensures that energy and momentum are distributed efficiently across scales. Cosmic connectivity. The same principles governing galactic currents could. By Orion Carl Daly 21. Aka. Essay on Relative Gravity to describe the mechanics of the universe. Extend to intergalactic interactions, where gravitational and electromagnetic forces connect galaxies within clusters, forming the cosmic web. Friction and currents in galactic dynamics exemplify the intricate energy flows that sustain the universe's structural integrity. By drawing parallels to thermodynamic and electromagnetic principles, this perspective enriches our understanding of how galaxies evolve, maintain stability, and contribute to the interconnected fabric of the cosmos. The delta phenomenon encapsulates the mechanisms of evolution, equilibrium, and transformation. By synthesizing insights from relative gravity, thermodynamics, and natural systems, it offers a profound framework for understanding the universe's principles. Whether exploring the cosmos, the origins of life, or the nature of consciousness, the delta phenomenon unites these realms into a coherent narrative of interconnected existence.